Welcome to this lecture on disinfection. In this disinfection lecture, I tried to talk about the importance of disinfection and then the various disinfectant available and then the terminologies used in the disinfection field when they want to refer to something. And then these are the major things I wanted to refer to. And then I will also talk little bit about the things that there are certain cases where we have to make sure certain pH in the water, and then why that certain pH is maintained, and then that reasoning I will give. And then those are the only few points I will try to cover here, and other than that I will not cover too many things here in this particular lecture. So because disinfection is essential as a water treatment, I think when I talk about water treatment, if I don't talk about disinfection, that's not complete. So that's the major reason I'm talking about it. Alright, now coming back to disinfection, why do we disinfect? If we ask that question, basically everybody will say bugs. So we want to get rid of bugs. But which bug we want to get rid of? We don't want to get rid of all the bugs. Not all. You cannot have a completely sterile system, water supply system. You can't have a complete sterile water. Even if it is a bottled water or any water you drink, there is always bugs there. Now what we don't want is not all of them, but we don't want anything that causes disease. This one we don't want. The disease causing one, we call them pathogens. Now you can appreciate when we talk about pathogen, there are hundreds, maybe thousands of them. Pathogenic bacteria are there. Now how do we know which bacteria we are going to target? Are we going to count each and every bacteria in the water to understand how many different types of bacteria are there, and then decide this water is safe to drink, therefore they say that okay, you can drink? And then if water utility have to do it on a daily basis, and then count all the try to detect all the thousands of bacteria, and then after thousands of bacteria is counted, they say okay, you can drink, and then you drink, and then that is not practicable. So now the situation now is, how do we ensure, how the water utility ensure that there's not pathogens there that will not kill us? Now the way that we look at this particular perspective is, we look at the origin of pathogens. The origin of pathogen is unfortunately we humans. So any pathogen that is going to be affecting us can mainly come from us. We start it, we have it, we excrete it, and then so if the water is free from this origin, so if you take the water without human contact, too much contact, then you can ensure you have done the first job actually to ensure most of the pathogens do not enter. The second source of pathogen is animals, because some of the pathogens can come from animal. So you also protect. If you can protect from animal, then that is good. Unfortunately, we can control the human, but we cannot control the animal. So therefore we always need some kind of disinfection for the water that is coming out of here. Now we don't rely in a drinking water distribution system. This is the first defense we have in ensuring the water supply is safe. There are other defenses that we take. For example, when you add coagulant, This coagulant makes bigger floc and then get all the particles, which particle include pathogens, and then they get all the particles out and then they remove the particle. So this is if there is a pathogen, these pathogens are also removed. Some of the pathogens are removed. Now sometimes you may have a situation that you have pathogens coming from other sorry, this is the first defense. So this is number one, defense number 1, defense number 2. Then you have defense number 3. If you remember, we did filtration. The filtration takes away some of the bacteria when they go through that filter medium. So here you trap some of the bacteria. When you do that one, then your water will be reasonably clean already. Reasonably clean. Now for this clean water, we take this clean water, again we apply disinfectant. This disinfectant is sometimes, most of the time in all over the world, it is chlorine, and in some places, for example Australia, Sydney, or Queensland, or I don't know, Perth, some parts of Perth, some parts of Adelaide, some parts of Melbourne, they use chloramine. You don't have to worry about what is chlorine or chloramine at the moment. Just concentrate on they apply the disinfectant. When they apply the disinfectant, they ensure that the water is safe to drink. So now, how do we ensure that it is safe to drink? So what they have done is they have taken the pathogen and then tried to list all the pathogen, 1, 2, 3, 4, 5, 6, and all the known pathogens together, and then they pick up the pathogen which is most difficult to kill. They pick up the one which is most difficult to kill with the disinfectant. Now this is the one they target to kill. So they ensure that if they kill this one, the most difficult to kill one, then they can ensure safe water. Now when we want to monitor the most difficult to kill one by disinfectant, most difficult to kill by, when they want to ensure the safe water, if we want to only count the most difficult to kill one, and because lot of processes are happening, and because pathogens are usually in a very low amount, we cannot monitor. These pathogens are usually in low amount. They are not in very high amount. The reason why is because if you take a population of people, say 1 million people, out of this 1 million people, maybe 100 people contain disease. And then out of this 100, maybe 20 contain maybe one type of pathogen, and then another 30 contain another type of pathogen, and then another somebody contain another type of pathogen. So they are going to be this much. But we have to find this pathogen is, therefore you can see that when 100 million people, 1 million people excrete their excreta or whatever, when they dispose their waste into the sewer, that will contain heaps of bacteria. Because our gut is full of bacteria, heaps of gut bacteria. These heaps of gut bacteria contain, usually we call them as coliforms. coliforms are the one that is going to be more in number in our body and in any warm-blooded animal. Any warm-blooded animal contain these coliforms in their body because that's the right temperature for them to grow. Therefore, they colonize our gut. And then, so you can imagine if you take a water which is which is affected by the excreta of human or animal or whatever, you will see lots of coliform and one or two pathogen there. So it's very hard to actually detect this pathogen. You can't detect the pathogen. So when they want to ensure the water is safe, they try to put the disinfectant so that they can ensure that they can kill the most difficult to kill bacteria. But when they want to monitor, they monitor this bacteria which is abundant in the food tract or your gut. So we monitor this one. So if this is 0 completely, nothing, virtually 0, nothing. Even if it is 1, that means that is considered unsafe. So they make sure that it is 0 and then they target the most difficult one to kill. So how do they ensure that, how they can ensure that most difficult one to kill is they use what we call concentration of the disinfectant, for example chlorine, times the time in minute. So they call it CT value. C stands for concentration, T for time in minute. Usually this is written in milligram per liter is concentration and minute is in minute. So milligram per liter minute is the one that's a concentration for CT. So there are tables available. From those tables actually you can understand how effective they are, what kind of disinfectant concentration you have to maintain, and then so those things I will discuss in the class, and that is the basic concept that is governing how the disinfectant is selected or particular how the particular disinfectant concentration and how long they want to expose the bacteria to in order to ensure that most difficult pathogen is killed. And we monitor the coliforms to ensure that this one is free of pathogens. So that's all I wanted to say here.